Wednesdays, we wear pink the 13th of this month of January. SWBA, you guys will be able to solve systems by elimination, section 5.3, okay? So, I kind of have little markers here, 5.3a and 5.3b. We're going to go through it all today, but just so you guys kind of know, they're kind of like two different parts of the same lesson, okay? So the first, what was that? No, there's one homework page, yep. It's going to be a similar amount of work as the last homework one. Okay. So elimination is our third and final method we're going to learn in order to solve systems of equations. Okay, we learned graphing. We said, wherever they intersect, okay, is a solution. We learned substitution, finding a variable, plugging it in for the other one, okay, substituting it. Now we're going to learn elimination. What does elimination mean, to eliminate something? Okay, get something out. Okay, something out. Cancel it. Get rid of it. Make it go bye-bye, okay? If you're eliminating something, you're getting something out. Okay, yes, NSYNC, bye, okay? Did I tell you guys that I once memorized that whole dance?
No, you can.
Yeah, so I don't know the whole thing anymore. But I know the chorus because it's incredibly simplistic. But, no, you don't want me to sing it. But I don't want anyone's ears to bleed, okay? And get banned by YouTube. What?
Do you remember some of the dances?
I do remember. I know the chorus dance. Maybe later in class. I don't have it. It's not recorded anywhere that I know of. I once learned the dance for a talent show in college. I was part of a group of 3 people that learned the dance. We called ourselves Out of Sync instead of In Sync. It was a joke. Okay, thanks for laughing, guys. Okay, anyway, so we have some rules we're going to follow for elimination, okay? I always kind of give you guys an outline, a step-by-step process of how we do things, okay? So this one, we're going to line up our x, y, and constant terms, okay? Once again, we'll understand what these mean more once we actually practice them. We're going to eliminate one of the variables by adding vertically. We're going to get rid of a variable. Then we're going to substitute the value of the variable in the original equation, write the ordered pair. Steps 3 and 4 are actually the same from before. Okay? Steps 3 and 4 are actually the same as our last 2 steps from before. Okay? Our first 2 steps, though, are what's new compared to substitution. So in example 1 here, we have 2 equations. X minus 2y equals negative 19. 5x plus 2y equals 1. Does that look like something that we could either solve by graphing or substitution as well right now? Yeah, because it's still a system of 2 equations. But we're going to learn this new one called elimination. So we want everything lined up. Well, here's what we mean by lined up. They're in the same orders. So the x's, we have both x's are first. Both y's are second, followed by the equal sign, followed by the constants. Now, you might see another problem later that's in a different order than this. And that's okay. What we mean by lined up, though, is that the set of 2 equations follow the same order as each other. Okay? The set of 2 equations follow the same order as each other. So everything is lined up right now, so to speak. So now it says we're going to eliminate one of the variables by adding vertically. So here's what I'm going to do. I'm going to turn this into an addition problem. So see how I drew that line underneath? And the plus is to signify we're going to be adding. Now, what is x plus 5x? We're going to add the x's. What's x plus 5x? 6x is adding vertically, so up to down. What is negative 2y plus 2y? Nothing. It's 0. Do I have to put 0 for things? No. Okay, I'm going to put it for now just so you can see what's happening. We don't have to, okay? Equals negative 19 plus 1? Negative 18. So now we end up having this equation. Like I said, we really don't even need that 0. Okay? We don't need that 0. I just have it there to show for a second, hey, we got rid of the y's. We eliminated the y's. Hence the word elimination is gone. This new equation, 6x equals negative 18. Does that look like something that we could have solved back in September?
Yes.
Yeah, I think so. How would we solve this equation? Divide by 6. And x is what? Negative 3. Now, in substitution, the one we just got done doing, when we found one variable, what did we do? Plugged it in for the other one. We're going to do the same thing. We use elimination to find the first variable. Now, we plug it in to one of the original two. Okay? So elimination or substitution, the difference is how you find the first variable. Then, you find the second variable the same way. So if x is -3, which one of these two, top or bottom, would we rather plug this into? Somebody give me an answer.
Bottom.
Okay, you said bottom. Okay, why do you want the bottom one, Brady?
Because it's shorter or something.
Okay. Are you just guessing, or do you believe that?
I don't know.
Okay, I'm just asking. Okay, Eli, what are you thinking?
Top one.
Okay, give me your reasoning.
Because there's only one number.
Okay, there's only one coefficient, that -2. Okay, Raquel.
We don't have to do the x thing. The other one, they have like 5.
Okay, so if we plug in the x, you don't have to multiply it by anything in the top one. So you're thinking maybe the top one. Okay. Now, is there a wrong choice? No. It's a personal preference. Okay. It seems like the majority of the class wants to go with the top one, so we'll go with the top one. But you definitely could go with the bottom one, and you'd be fine.
Hey, knock up.
Okay. So let's plug this into either equation. Like I said, we're going to try the top one right now as a class. -3 minus 2y equals -19. Now, if you don't like that -19, you're like, oh, one's a lot smaller, then you can do the bottom one. Okay. Anyway, we're going to add 3 to both sides. And we get -2y is equal to -16. Divide by -2, y equals 8. And now we just write our answer as an ordered pair just like we did before, -3, 8. And that's elimination. This is my personal favorite one, honestly. Now, the thing is, we'll learn more and more about it, that depending on how you're given the equations, sometimes it's just easier to use one method or another depending on how they're given to you. There might be more set up for a certain method than others. Personally, elimination is my favorite. So once again, we had to make sure everything was lined up. X, Y equal constant. Okay, everything's good. Added vertically, eliminated a variable. Oh, now we have this chapter 2 equation. Solve it. Plug it back in. Let's go on to example 2. We got to check, is everything lined up right now?
Yeah.
Okay, you have our X's, you have our Y's, you have our equals, you have our constants. Everything's lined up. Okay, good. Okay, yes.
What happens with the rock?
We'll cover that. Yep. We'll have an example like that, okay? So now, when everything's lined up, we're going to add vertically. Now, right now, do you guys have a guess as to which variable is going to eliminate? Okay, why are we thinking the x's are going to eliminate?
Because 2x plus -2x is 0. So then
Okay, -2 plus 2 is going to be 0, right? We have a 2 and a -2, so those are going to end up adding to 0. Now, do we notice that those are the same number 2, but what's different? They're different signs, right? One's positive, one's negative, okay? So let's add here. 2x plus -2x we said was 0, so we don't have to write it. What's 3y plus 4y?
7.
7y. As I say, the answer equals 14. 7y equals 14. Jack, how do we solve this equation? Divide by 7. Y is 2. Alice, what do you do when you know one variable?
You plug it in for one of the original ones.
Yeah, you plug it into one of the original equations and find the other one, okay? Does anyone have a preference here as to which equation we should use, top or bottom? Okay, top. Why are you thinking top? Okay, no negatives, smaller numbers. Cool, let's do the top. Sounds good to me. 2 times x plus 3 times 2, instead of the y, equals 6. Well, 3 times 2 is 6. 2x plus 6 equals 6. Subtract 6. 2x is 0. Do we panic here and say it's IMS or no solution? No. We continue to divide and say divide by 2. What's 0 divided by anything? 0. So x is 0. Corey, do you have a question? You stretching. Okay, you're good. Just want to make sure. 0, 2 is our answer. If you had a question, I didn't want to ignore you. Yeah, Brady, what's up?
So on example 1, when you add -3,
Yep.
so why did you add 3? And then the opposite of example 2, you did multiple of 3.
Yep. So it's all about what was happening in the original problem, okay? Hey guys, Brady was asking a good question here, so I wanna highlight that, okay? He's saying, well, Mr. Kossel, in the first example, when you plugged in -3, you ended up adding 3. Second example, when you plugged in 2, you ended up multiplying. So what's the difference? Why did you add in one, but you multiplied in the other? Well, Brady, it all comes down to what was happening in the equation, okay? So in this equation, we replace the top one. Was x multiplying with anything?
No.
No, so we didn't need to multiply with anything. Was y multiplying with something here?
Yeah.
So we had to multiply with something there. So it all comes down to what's happening in the original equation, okay? Then, after we multiplied, we subtracted, just like here we added. We did the opposite of what was there. So this one was like one less step because the x was by itself. Okay, continuing on. Now, sometimes you have to change the signs of one of the equations before you can eliminate a variable. It's kind of like you're subtracting instead of adding, okay? Because like instead of like you can always add a negative or subtract, they're really the same thing. Because here, even though example 3, everything's lined up into x, y's equals constants,
It doesn't work.
it doesn't work. Why doesn't it work?
You get 1x plus 8y equals 20.
Yeah, you get 8y. Why don't the y's eliminate even though they're both 4?
Because they're both positive.
They're both positive. They have to be what?
Negative.
Both negative?
No, 1 negative.
One negative, one positive. They have to be different signs. Okay, so here's what we're going to do. We can't just say the bottom 4y is negative, now we're good to go. You can't just change one thing in an equation, can you?
No.
What do we always do when we change something to an equation? You have to do the same thing to other side. You have to make it fair. Okay, you have to make it equal. Okay, so here's what we have to do. We're going to multiply this entire first equation, or excuse me, the entire second or the first equation, it really doesn't matter, by a -1 or by a negative. Okay, by like a negative, which is secretly like a -1. Okay, by a negative, which is secretly like a -1.
Including the 8.
Including the 8. Yep, you have to do it to both sides here, okay? So we're going to do -1 times -2x. Okay, I'm going to rewrite what we get off to the side here. Okay, -1 times -2x, which is going to be positive 2x. -1 times positive 4y is -4y equals -1 times 8, which is -8. So I took that bottom equation. We ended up just changing every single sign. The positive became negative. The negatives became positive. Now, I did not need to change my top equation, so here's what I'm going to do. I'm just going to rewrite it. Does anyone have an idea of why I bothered rewriting it, though? That's just it. Jocelyn, can you say that louder?
So it lines up and it actually does it properly.
Yeah, so everything lines up still, okay? Because I rewrote the bottom one somewhere else, I want to keep the top one there lined up with it so it's ready to go. Now, if we were to add, would we eliminate a variable? Yeah, what variable would eliminate, the x or the y? The y, because now they're the same number 4, but different signs. Okay? When they're the same number and different signs, you're ready to add. Okay, let me say that one part one more time. When they are the same number, but different signs, you're ready to add. Okay? So let's add these two. What is 3x plus 2x? 5x. That 4y plus -4y is at 0 we talked about. And 18 plus -8 is 10. So we have 5x is equal to 10. So 5x equals 10, we can divide by 5. This turns back into a chapter 2 equation. X is 2. Any questions on how we got this far to get x? Okay. Now what would you do after we found x? Plug it into one of the original two, yep, to find y. Okay, anyone have a preference on the top or the bottom? Top, okay. Now, before, when we had messed with an equation, we always said we don't want to do it with an equation we messed with, right? Because it was possible we made a mistake when we kind of changed around an equation for substitution. We said, well, let's not plug it into the one we changed. So you wouldn't want to plug it into either of the light blue ones, the ones that we changed, but either of the original two are okay. I heard the top. We can choose the top. It doesn't have negatives. Okay. It has bigger numbers but no negatives. So it's kind of a trade-off of what you'd rather have. So let's roll the top, though, because that's what I heard. 3 times 2 plus 4 times y equals 18. 3 times 2 plus 4 times y equals 18. As we plug this in, or as we continue to solve, 6 plus 4y equals 18. Subtract 6. 4y equals 12. Now we have 4 times y, so we can divide that. And y is 3. So how do we write our answer? 2, 3, x, y. Questions on that one? So we had an extra step here. What was that extra step? Multiply one of the equations by -1. Now, did it matter which equation we multiplied by -1? It really didn't, guys. It really didn't, because here's the thing. If we had multiplied the top equation by -1, we'd have gotten a -4y as well. Okay? And here's all that would have happened. Instead of 5y equals 10, we'd have had -5y equals -10. But a negative divided by a negative is still a positive. So no matter what, no matter which equation you made multiplied by a -1, it was going to work out okay. Does example 4 kind of look similar? Okay, our first question, does everything line up? Okay, we have our x's, our y's, our equals, our constants. Okay, everything lines up. Second question, adding. Okay, well, before we can add, we can say, are we going to eliminate anything if we add? Let's make sure the adding is useful. No, we won't. In order to get something eliminated, to be ready to add, what do you need? You need 2 things.
You need something to cancel out.
Yeah, you need something to eliminate. And how do we know if it's going to eliminate? You need to check 2 things to make sure it's going to eliminate. Same number, different signs. Do we have the same number?
No. Oh.
2. Do we have different signs? No, that's what we need. Okay, we kind of go through this checklist. What do we need? Oh, we need the same number, different signs. Same number, different signs, okay? Has anyone seen Shrek? Shrek, the movie Shrek, okay? Donkey, when he's going to look for a flower. Blue flower, red thorns. Blue flower, red thorns. Blue flower, red thorns. Man, this would be a lot easier if I wasn't colorblind. Anyway, so same number, different sign. So I'm just thinking of blue flower, red thorns, same number, different sign. Anyway, all right. So we need to multiply one of these equations by -1 to change a sign. Okay? Jack, what equation do you want to multiply by -1? Top or bottom? Okay, cool. Is there a reason you chose the bottom so quickly, Jack?
No.
Okay, that's fine. If there was, I was pretty curious as to what it was. So, and once again, I'm just going to rewrite the top one, even though we're not changing it in the slightest. Distribute that -1. I'm going to get the -2x plus 5y equals -13. Questions on that? Is it starting to look like a lot like our other problems?
Yes.
Okay, Courtney.
Does it? Do you have to multiply by a 1?
What do you mean?
Like the end of the number besides 1.
Okay, so let's think about what would happen. Okay, Courtney's question: does it have to be a 1? Could it be a -2, -3, -4? If we multiply by a different number, like -2, would these be the same number anymore?
No, I was multiplying. I multiplied the top one by a 5.
Yep, that would work. Yep.
Because then it would make the 5s the same.
Yep. We'll talk. That's actually our next kind of problem we're gonna do. Yeah. So I'll get back to explaining what you're gonna say, if that's okay with you, on our next set of problems. Okay. I actually want you guys to go ahead and finish off this set of problem. Okay, this problem here. And when you have it or have questions, I want you to go ahead and raise your hand. So as we do this, we're going to be adding, and we get 2x plus -2x is 0. y plus 5y is 6y. Negative 5 plus negative 13 is negative 18. So now we just divide, by 6. Now something I saw a lot of people actually get tripped up on here, so I just want to hit it one more time for everyone. Negative divided by a positive will be a negative 3. I saw that actually a lot here, so I just wanted to clarify that for everyone again. That I know it's kind of, we're getting back in the groove of things still. Negative divided by a positive will be a negative 3. So now we take that and we plug it into either equation. I'm probably going to plug that into the top equation personally. 2x plus a negative 3 equals negative 5. So now I'm going to add the 3 to get rid of a negative 3 because negative 3 plus 3 is 0. 2x equals negative 2. Divided by 2. X is negative 1. Write my answer. Negative 1 comma negative 3. Questions on that at all? Okay. Let's continue on. Okay. So, here's a practical example of this. Okay? Sometimes you need to figure out what two numbers can add to a number but subtract to another number. Okay? Sometimes you actually would need to figure that out in real life. Okay? So find two numbers whose sum, adding, is 64 and whose difference, subtracting, is 42. Okay? So two numbers. Do we know the numbers right now?
No.
Okay, no. What do you want to call them? Or you have what the numbers are? Okay. What do we want to call these numbers if we don't know them?
X's.
Variables. Okay, x and y. Okay, they need to be two different numbers, so they need to be two different variables. Can we do what?
M and Q.
Sure, we can do m and q. Okay, so two numbers, m and q. What do we know about m and q, these two numbers? You can call them whatever you want.
They're going to become 64.
Okay, they're going to become 64 by what?
Multiplication.
Not by multiplication. Adding. So m plus q equals 64. What else do we know about m and q? M minus q has to be 42. Hey, do we have a system of two equations?
Yeah.
Does this look like a problem that we would have been given just a moment ago? I sure think so. Hey, Ozbobs. Okay, so now, can we add these two with elimination?
Yeah, sure.
Is everything lined up? M's, Q's equals constants? Yeah. And if we add, would we get rid of a variable? Yeah. Okay, let's add. What's m plus m? 2m. Q plus negative q is 0. 64 plus 42. 106. Now we divide by 2. M is 53, yep. So that's one of the numbers. How do we go back and find the other one?
Plug it in.
Plug it in. To which one do we want to plug it into?
The bottom one.
Cool, let's plug it into the bottom one. 53 minus q equals 42. Subtract 53. Negative q equals negative 11. Divide by negative 1. Q is 11. So what are the two numbers? 11 and 53. And this one we actually don't have to write as an ordered pair because it's not a coordinate. We're answering another type of problem. We're saying, what two numbers? 11 and 53. It really doesn't matter which number comes first in this scenario because it's a word problem, okay? Yeah, what's up, Eli?
Wouldn't it be easier if you take the number that you already have and get it up to 64? Like you take 53 and then add up to 64 and then you get 11.
Yeah, so you're essentially wanting to plug it in the top equation, in which case you'd subtract by 53. 64 minus 53 is 11. So same idea, it's just kind of a different way of thinking that mentally.
We haven't even gotten to B.
Yep. Questions on that?
Oh, we're doing B today too? Yes.
Okay. Alrighty.
Imagine 30 minutes of
Let's look at... Okay. What we're going to do actually for soccer conditioning is you run, and then you do math problems, and then you run more. So we do math problems for breaks, okay? Yeah. Yes. And then do math problems while you run, okay? So, 4 times one number minus 3 times another number is 12. 2 times the first added to 3 times the second number is 6. Find the numbers, okay? Another story problem here. How many equations do you think we're going to write here? Probably 2, right? We've been dealing with 2 equations over all of these. How many variables do you think we're going to have? Probably 2, but 2 in each equation, but the same one. So kind of 4, but kind of 2, depending on how you want to answer that, right? 2 different variables, but we'll see a total of 4 in our equations if you add them all up. Okay. Does anyone have an idea of what the first equation might be? Okay, Abby?
4x
Okay.
minus 3m.
Okay. I love it. 4 times one number, 4 times x, minus 3 times another number, a different number, m, is or equals 12. Very good, okay? What would the second equation be based upon this first equation? Okay, Eli?
2x plus 3m equals 12, or equals 6.
There you go. 2x plus 3m equals 6. 2 times the first. 2 times what number came first? X. 2 times x. Added to, so plus 3 times the second number. What was the second number? M, we called it. 3 times m is equal to 6, okay? So now do we have our system of 2 equations? Okay. Now, any questions on how we got this? Could we solve this from here?
Yes.
I trust your ability. We're going to continue on, actually. Okay. If the desire in you to know the answer is that big, it is 3 and 0. Okay. Let's go on to B. Elimination using multiplication, okay? So sometimes you have to multiply first. This is actually what Courtney was talking about a moment ago, okay? 2x plus y equals 3, negative x plus 3y equals negative 12. We're still going to follow our same steps, okay? Is everything lined up here? Yeah, it is, okay? We have our x's, we have our y's, we have our equals, we have our constants. Everything's lined up. But now if we add, are we going to eliminate either the x's or the y's? No, okay? What 2 things do we need in order to eliminate something? We need opposite sign, same number. Same number, opposite signs, however you want to say those, okay? For the x's, do we have opposite signs?
Yes.
Okay, do we have same numbers?
Yes.
No, okay? For the y's, do we have opposite signs? No. Do we have same numbers? No, okay? So we need to change something on one of them, okay? Now here's the thing. If we change the x's, we need to make it so they're the same number without changing the sign. If we change the y's, we need to change the number issue and the sign issue. Okay? So we would need these to be the same number. Now before we multiplied by a negative 1. Courtney was asking, can we multiply by a different number? What number might it be helpful to multiply this bottom equation by? 2. Why are you thinking 2? Because the x on the top is a 2x. So if this was a negative 2x, would this work out nice and neatly? Yeah, it totally would. Okay? So instead of saying, what if fairy tale land, let's make it happen. So we're going to multiply this bottom equation by a 2. Are we changing the top equation at all?
No.
Not even slightly. 2x plus y equals 3. Top equation stays the same. This bottom equation, we're going to multiply every single thing by 2. 2 times negative x is negative 2x. 2 times 3y is plus 6y equals 2 times negative 12, negative 24. Ha ha. Now with these new 2 equations, everything's lined up, and are we ready to eliminate? Yeah, because our x's have the same number, 2, and different signs. That's awesome. Questions on how we got this far?
No.
Awesome. Now, do we have at this point, is this the same kind of problem like we had before?
Yes.
Yeah. So we add to eliminate these. 2x plus negative 2x is what? 0. That's why we did that. Y plus 6y. What's y plus 6y, Ava? 7y. I put you on the spot. Equals 3 plus negative 24. What's that? Negative 91. So now what do we do? 7y equals negative 21.
Divide by 7.
Yeah, divide by 7. Get y by itself. Y is negative 3. Well, plug it into either original 2, okay? Raquel, why are you saying top?
Because we could have messed up
Okay, we could have messed up doing something here in the bottom equation. You can still plug it into the original bottom equation if you want the OG one. But the numbers do happen to be bigger, and there's more negatives. Okay, so let's plug it into the top. Okay, but not one of the ones we made changes to. Okay, so as we plug this into the top, 2 times x plus negative 3 equals 3. 2 times x plus negative 3 equals 3. Boom, add 3 to get the variable by itself isolated. 2x equals 6. Now, we divide by 2, and x is what? 3. So we end up with our answer being 3 comma negative 3. This y was a negative 3 because it was negative 21 over 7.
Oh, okay.
Is that good?
Yeah.
Okay. Can I show you guys something real quick? You guys don't have to write this part down, but can I show you something? Okay. Let's say I took these original 2 equations. I mean, even if you said no, I was going to do it, okay? Just so we're clear. Let's just say, don't write any of this down, okay? Don't cross anything out. Don't do what I'm doing right now.
I've never had a student say no.
I don't think so. Maybe they just know better. Okay. Let's say we have these original 2 equations again, okay? 2x plus y equals 3. And negative x plus 3y equals negative 12, okay? And let's say, instead of getting the x's to eliminate, I want to get the y's to eliminate, okay? Well, what would I need this top y to become in order for these to be able to add to 0? I'd make it a negative 3. So I'd have to multiply this top equation by a negative 3. So I do that, I get negative 6x, negative 3y equals negative 9. And the bottom equation would say negative x plus 3y equals negative 12. Okay, well then we go to all this nice stuff of adding. Negative 7x plus 0 equals negative 91. Divide by negative 7. X is positive 3. Hey, did we get the same x as before? Okay, it's a good sign. Plug it into either equation. Let's say we plug it in the top again. 2 times 3 plus y equals 3. 6 plus y equals 3. Subtract 6. Y is negative 3. Is that the same exact answer? 3 comma negative 3. So did it really matter which variable we eliminated? No. Now, would you guys potentially have a preference on multiplying an equation by 2 and multiplying an equation by negative 3? Yeah, you might. Okay, so that's where it comes down to. You're going to have a lot of choice. Okay, you're going to have a lot of choice on what you guys want to do. And so you guys are going to have to make these choices saying, oh, what would I rather have happen? Okay, or what's easier for me? Okay, and so Ava might make a different choice than Isaac makes. And that's okay. It's perfectly fine to make 2 different choices. Okay, and they might actually make a different choice than Elijah makes. Okay, we have some scenarios where we can make a bunch of different choices. Okay, questions on that? Okay, we're actually going to skip that second example and go on to the next part. To where sometimes you have to end up multiplying both equations. Right here, we have everything lined up. X, y equal constant. But now, can I make my 5 look like a 7? No, we want the x. We would want either the x or the y's to be the same number, different signs. I can't make my 5 look like the 7. Before, on the last example, I was able to turn in my negative x into a negative 2x to make it look like it. Or I was able to turn in the y into a 3y and make it look like it. Here, I can't turn 5 into 7. Can I turn 7 into 5? Okay, I could turn them both into 35, right? I could turn them both to the same number. Okay, I could also do it with y's. Can I turn 8 to 12? No, but I can turn them both to 24. So this is kind of where our what do we want to do scenario pops up. So don't write this part down yet, okay? Let me kind of give you the scenarios. So like Elijah said, we can multiply these x's to get up to 35. What would I have to multiply the top equation by for that to happen? 5. What about the bottom equation? 7. Now, are these the same signs or different signs? Same. So it has to be either a -7 or a -5. Exactly right. Doesn't matter which. So option 1. Multiply by a 5 and a -7. As long as one of them is negative, doesn't matter. Option 2. If we were to do the y's, what would we have to multiply the 12 by? 2. What would we have to multiply the 8 by? -3, because once again we need to take care of the signs. Very good, Abby. So here's our options. Would you guys rather multiply by 5 and -7 or by 2 and -3? Most of us are probably going to say by 2 and -3, okay? And what that's going to determine is which variable we're going to eliminate. So we want to look at both the x's and the y's and say, hey, after analyzing this, after looking at this, which one's going to be easier? Okay? This is going to give us smaller numbers if we get 12 and 8 to 24, haha. Versus if we get 7 and 5 to 35. Okay? Any questions on that at all? Seriously, if you have them, I want to answer them right now. Okay. So on that note, let's multiply the top equation by 2 and the bottom equation by a -3. So on the top equation, 2 times 7x, that's 14x. 2 times -12y is -24y, haha, equals 2 times -22 would be -44. That bottom equation, as we multiply -3 times 5x would be -15x. -3 times 8y, -8y, would be +24y, equals -3 times -14 would be +42. Any questions on how I got any of these numbers in these two new equations? So now does it look like it's a lot more ready to add? Yeah, that's good, that's good. Now, I know these numbers look really big right now, don't they, compared to before? Mm-hmm. What if I tell you this one's actually going to work out nicely? What's 14x plus -15x? What was that? I didn't hear it. Oh, okay. That's the spirit. 14 plus -15. -1x. Negative x.
That's what I said.
Then you should have repeated it yourself. You got to take chances. Okay? -24y plus 24y. 0. Do we have to write it?
No.
Nah. -44 plus 42. -2. So now we end up with this equation. Please write it down right now if you don't get it. So we have -x equals -2. Is x by itself yet? No, but it's really close, right? Okay. Divide by a -1. And x is 2. So what do we do with that x now that we know it?
Plug it in.
Plug it into either equation. It really doesn't matter which. Okay? Really doesn't matter which. Do you guys have a preference? Bottom? Cool beans. Let's plug it on the bottom. Smaller numbers, right? Okay, literally every number is smaller. Okay, so 5 times 2 minus 8y equals -14. Everything stays the same except for x is 2. What is 5 times 2? 10. 10 minus 8y equals -14. Subtract that 10. -8y is equal to -24. Haha. Never gets old. Okay. Divide by -8. Y is 3. So our answer ends up being 2, 3. And it would have been the same thing had we multiplied the x's to 35. We'd have gotten the same answer. Questions on that? What was that?
Nothing.
I didn't hear it.
I said, can we get our homework?
Okay. We're going to do one of these other two quickly, and then we'll be done. We're going to only do one of the other 3 examples. Yep. Good question, though. Okay, we're going to skip that second example, okay? And if you end up needing more help on this later, okay, watch the videos, ask me for help, that kind of stuff. Okay, I'm more than willing to help you guys. Okay. Now we can still come across these parallel or coinciding lines or no solutions or IMS, okay? And it's going to look very similar to what we've had before when we have those. So let's take this first equation down here at the bottom. 3x minus 5y equals negative 6, and negative 9x plus 15y equals 13. Well, we want to get these equations to be the same numbers, different signs, okay, because everything's lined up. What do we have to multiply the top equation by? 3. Bottom equation can stay the same. Top equation is 9x minus 15y equals negative 18. Bottom equation is negative 9x plus 15y equals 13. Okay, this is looking weird, right? Yeah. So what's 9x minus 9x? 0. What's negative 15y plus 15y? 0 equals negative 18 plus 13, negative 5. Wait, does 0 plus 0 equal 5, negative 5? No. What's our answer? No solution. Now, what do you think would happen if it was 0 plus 0 equals 0? IMS, because that's true, right? No variables, and it's false, no solution. No variables, and it's true, IMS. That's just kind of the general rule of thumb. So whether you run across that by whatever method you do, that's going to be the case, okay? So it's on the top right of the board as well if you need it. Do numbers 2, 4, 6, 8. Who do you appreciate? Okay. 16, 18, 22, 24. Haha. That was kind of cool. I heard like all these papers flip at the same time. That was pretty cool unison. It was like boom, surround sound. Okay. So I want you to do those 8 problems. Okay. 2, 4, 6, 8, 16, 18, 22, 24. Oh, yeah.
There's no one. I'll just say number 2.